Good morning, students. I hope everybody's fine. And we are going to start with this second session on UTM. And it's going to be all dedicated to mapping equations. So at the end, I hope that you'll be capable to explain the geometry of coordinate transformations, UTM to geodetic and vice versa, as well as spell out the terms in the mapping equations. I'm going to make use of a formulation that is spelled out by the US Mapping Service. And here we have the transformation from geodetic coordinates to UTM. So we know the geodetic coordinates of a point, and we're going to compute the UTM coordinates. So what we have here, of course, we're computing the n prime and the e prime. These are the distances on the mapping plane from the equator to the point of interest, and this is from the central meridian to the point of interest. And we're going to discuss here something that is interesting. We have first this term 1, and that is going to be understood as the main term, and we have a corrective term, and this is for the computation of the northing. For the computation of the easting, we have this term for P as the main term, and we're going to have the rest as a correction. And after we compute the n prime, of course, we can apply the constant. We can get 10 million and subtract from it n prime. These are for points in the southern hemisphere. If we are doing computations in the northern hemisphere, the northing is going to be equal to the n prime. For the eastings, if the point is located east to the east of the central meridian, we're going to add 500,000. If the point is to the west of the central meridian, we're going to subtract 500,000 from E prime. So let's look at the geometry. Okay, this is a nice diagram that I built for you guys, and you're not going to see that anywhere. And what we have here is a transformation from geodetic to UTM. So we know the coordinates, the geodetic coordinates of the point, phi, this point here, okay? Phi and lambda, okay? So it is the projected meridian and projected parallel are shown as curved lines. We know that the projected parallels are concentric facing the poles, and we know that the projected meridians are curved lines facing the central meridian, which is indicated here by its longitude lambda sub 0. What we want the components of the coordinates n and e. Okay, so we want this term here, this guy here, and we want this guy here. Of course, we don't have it. What we can do is we know that the latitude of the known point, and therefore we can compute the arc of meridian. We can compute the length from the equator all the way to the point, the arc of meridian, along the central meridian. Okay, we know that this is represented as with a deformation that is equal to the coefficient of distortion of, sorry, the coefficient of scale reduction, k sub 0. Okay, so we can compute b. B here is the length of the arc of meridian, and then multiply by k sub 0. We have this distance, and everything that we have to do now is compute this correction. Okay, so as I told you before, we have one initial term, and we have the rest of the terms are nothing else but corrections to account for this distance here. If you go to the easting, we also have here, this is the projection, this is the E coordinate, or the easting of the point, but we want this segment here. Okay, that's what we want, because we want to get the no, actually, I'm sorry. This is what we have. We have this guy here. Okay, I'm doing the other way around. So we know this guy here because this corresponds to the distance on the equator between the central meridian, lambda 0, and the longitude of the point, lambda. Okay, this is the main term. It's going to be 4p. This is nothing else but the arc of parallel. And then all the rest of the terms will be a correction in here. Okay, so it is, geometrically speaking, is well, after we look at it and we think a little bit, we understand it makes sense. Now the equations. So, I mean, presenting the equations they are. Here is the first term, the main term, to compute the northing. B is the arc of meridian, and multiplied by k sub 0. And all the other terms are nothing else but corrections. So these are the terms here that relate to the computation of the northing. Okay, and there is a constant term p that is given in here. Now let's talk about the easting. The easting, I told you that the main term is 4 multiplying by p. Okay, and if you look at the expression here, I'm sorry, if you look at the expression here, n cosine phi delta lambda, we have seen this before. Okay, this is the arc of parallel. Okay, so which means that the term 4 times p is the arc of parallel, and then we have all the rest, the remaining terms that will be seen as corrections. Here we have a few additional terms that are simplifying. T square is the tangent square of latitude. N square, the square of the second eccentricity multiplied by the cosine of latitude. N is the radius of the prime vertical. Term P we have talked about already. And this is the meridian, the length of the meridian arc. Okay, and this quantity B is going to be computed by this expression, in which we have here the major semi-axis, the eccentricity, latitude of the point, rho prime is for radian conversion, and we have these terms A, B, C, D, which are given in here. So they are nothing else but power expansions as a function of the eccentricity. Okay, and this term B here corresponds to this B here. Okay, not to be confused to the arc of meridian. Okay, this is a straightforward, direct computation. Now, if you go from UTM to geodet coordinates. Now we know the UTM coordinates of a point. We want to get the geodet coordinates of the point. So here are the expressions. We computed the latitude directly. For the longitude, actually I computed the longitude as with respect to the central meridian. So here we have, this is the phi prime, which is the footprint latitude. We discussed that before. I'm going to explain again. So this is the main term, and we can see these terms here as a correction. For the longitude, we also have this term here, 9q as the main term, and the rest can be seen as a correction. For the equations that follow, n naught corresponds to the false coordinates, 10 million if the computations are in the southern hemisphere, 0 if the computations are in the northern hemisphere, and E sub 0 corresponds to 500,000, which is, of course, we know the value of the easting along the central meridian. And here we have a diagram similar to that one, but now what we know are the coordinates, UTM coordinates, northern easting of the point. Okay, and what we want to compute is essentially the longitude. As a matter of fact, we are going to compute the difference of the longitude between the longitude of interest and the longitude of the central meridian, and we want to compute the latitude. Now, something that is interesting, that if we project the latitude of the point on the grid, okay, so all these points here in this curve, if I were a normal person, I would be drawing these a straight line. So I just want to highlight that all these points here have the same northing, which means that at this location, when the northing intercepts with the central meridian, this corresponds to the latitude of a different point. Okay, that's the phi prime, phi 1, or phi prime, and that is the foot point latitude. Okay, so which means that we know this guy. Okay, and what we have to do now is going to be, compute a correction. The correction is just this distance here. Okay, this distance. This likewise with the easting, we know the value of E. This is the projection. Okay, these are points of a similar value of E. Again, this should be a straight line. And what we want to do then would be to compute a correction. So again, apart from this nice drawing that I have done, not even Picasso would be capable of drawing something so nice. Apart from that, everything is very clear, should be clear. So here are the terms, the term 7, term 8, term 9. So something that I probably should do is to go around here. The notation is known. This is the prime vertical radius. This t represents the tangent square of phi. N is as defined. K sub 0 is the is 0.9996. So all the terms here are known. This value q, which has to do with the distance on the mapping plane. Q is 10 to minus 6 multiplied by E prime. Here we have, yeah, I got this right this time. So term 9. So anyway, we have all the terms here that allow for the transformation. Now, what about the latitude of the foot point, foot point latitude? It can be computed by this expression here, which is length expression. So to express that, um, we just use these terms W, F, G, H, which are given here. This is F, which we need to compute this term A here. And all the terms here are again known. Some others introduced just for simplification. F is the flattening. We have the term G in here. We have H, W, N prime, and we have N sub-zero here, in naught and E naught, which are the coordinates of the northern equator and the eastern, the central meridian. Okay, so this is uh, the session on the mapping equations. Something that I probably should highlight to you are the references that we have, and here they are. I'm going to be repeating the reference. I didn't do that the first time, but I'm going to do that now all the time. Okay, so very soon we are going to have a discussion on the angular relations. Okay, take care. Talk to you soon.